My name is Tim Marran and I'm the Product Manager for chainflex cables here at igus. One of the most common questions we get about working with our cables is how to properly terminate the shield. Today, we're going to talk about the different types of shields that are offered in the cabling market, what makes a good shield for a continuous flexing cable, as well as the different popular ways to actually terminate a shield. How is a shield made? Well, there are many different structures, but the three main ones that igus uses are a tinned copper braided shield, a tinned copper spiral shield, and a foil shield. Let's look at the differences. So for a tinned copper braided shield, you can see the strands of tinned copper are braided together. And what this means is they're intertwined at a very low angle. If we had a relatively high angle, you would notice the gaps in my finger would be similar to what you would see on the cable, and there wouldn't be as much coverage. Why do we need coverage? Well, the whole purpose of a shield is to protect against EMI, or electromagnetic interference. So if we have a low or a tight angle shield, we actually can offer up to 90% optical coverage on our continuous flexing cables. And what we found at igus is the lower the angle, the better it actually works in a continuous flexing application. What does that mean? It means it'll stand up to millions of flexing cycles inside a cable carrier. The next type of shielding that we can talk about is the spiral shield. This is where we have tinned copper, but instead of it being braided, it is wrapped helically around the cable. The reason we have this particular structure is for more torsional applications or twisting applications, such as on a 6-axis robot. This is important because if you were to install a tight braid angle shield on a robot, the shielding would actually twist and turn against itself and would end up breaking the tinned copper strands. That can not only damage the cable itself by poking outside of the jacketing, or worse, internally into the conductors on your particular cable, but it also actually reduces its original ability and function of protecting against EMI. The third type of shielding we have is called a foil shield. And here you can see it's a metallic tape or material, typically aluminum, and it is wrapped around the cable, usually in the outermost layer, covering multiple conductors or the entire cable. Foil shielding is very popular in static wire and cable because it is the most cost-effective way to shield cables. At igus, what we have found is that typically just a foil shield is not the best for a continuous flexing application. That's because after thousands and thousands and millions of cycles, again, the shield in a foil shield tends to break down much quicker, and therefore you're not protecting against that EMI anymore. That's why at igus, if we do offer a foil shield, it usually will also come with a tinned copper braided shield on the outside portion. Now, let's talk about popular ways to terminate a shield. As we've seen with foil shielding, it's the most common in static cable. So this is what many connector manufacturers are used to seeing. For that, there are also different types of metallic tapes that are offered that we can use over braided shields if there isn't a foil shield also present. This is where you can see the cable sample that I have in my hand, where a tape was actually added. So this metallic tape wasn't actually part of the cable structure, but because it's an easier way to terminate the shield, that's applied and then we can do something else with it. We also have a clamp. So for this particular cable, which has a braided shield, the braided shield was actually pulled back and draped over the jacket of the cable, and then the clamp will actually go around and make contact with all of the tinned copper strands that used to make up the then braided shield. We can then see that it's also attached to this metallic plate, which is part of the connector, that will attach to the machine. Finally, there are even some connectors that offer specific grounding options. For this particular RJ45, which is common and popular for Ethernet cables, you actually have these metallic parts that will clamp down on the shield to make sure you have good contact with the shield. It also comes with a foil strip or foil tape to attach to a braided shield if it's not already a foil shield. Then you can just simply slip the back shell over the connector piece, and that ensures that the grounding is stable. So how do you actually terminate a braided shield? To do this, we use a specialized tool called an awl, or a pricking awl. And it has a point much like a needle. And how we use it is you put it in between the braided layers and gently pull back. And what that does is it allows the tinned copper braids to be pulled into strands. So then we can pull all the strands of the braid around so that it's on one side of the cable. And then once we have all of our strands together in a grouping, what we do is twist or pigtail them together. And then we have a contact that you can enter into the pin in a connector, or you could attach a jumper wire to it and ground the shield that way. If you have any questions, please leave a comment below, or you can send an email to the address on screen. For more details on cable shielding, please click the link in the details below. Thanks for watching.